And everyone, Marwan King, AI here. What's going on? So today we're going to walk through a pretty interesting project build. We're looking at it less like a straight tutorial and more like a comparative analysis. We came up with a really detailed plan, broken down into four big prompts or steps for building a specific app. Then we took those exact same instructions and applied them to three different ways you might build something today, using AI app building platforms conceptually like Lovable.dev, Tempo.new, and Google's Firebase. The whole point is to see how these different approaches handle the same complex job when they're just given identical detailed text instructions. It's a way to explore the strengths and challenges inherent in each method. The project itself is called Koha Ledger. I chose Koha because it's a Maori word that means something like a gift or a contribution, especially one given within a community. It felt right for an app that's all about managing shared finances fairly. Functionally, Koha Ledger is designed to be a solid platform for any group sharing costs. Think roommates splitting rent and groceries, friends managing expenses on a trip, maybe with small teams tracking project costs. It needs to handle tracking expenses accurately, figuring out who owes who in real time, dealing with different ways people might split the bill, like take down a specific item on a receipt, managing those receipts securely, handling different currencies, and keeping everything safe and organized for everyone in the group. So definitely aiming for something more robust than just a simple bill splitting tool. Now, functionality is key, but we also want something specific that's a specific look and feel, something premium and clear. We definitely want an aesthetic called luminous depth. So let's break that down. A dark theme. We start with a mandatory dark background. This helps content stand out, reduces eye strain, and generally gives a more focused, sophisticated vibe. Common in finance or Pro Tools. Glass morphism for UI panels like sidebars, cars, and modals. We specify glass morphism. That's an effect that looks like a frosted glass. It uses background blur, backdrop filter, and a slight transparency on a base surface color. It creates a nice sense of visual layers and depth without using it. Strategic gradients. We're not going crazy with gradients everywhere. The prompt calls for using them purposefully. So it's going to visualize positive or negative balances to highlight an active button state within category tags using our core palette colors like the violet primary and the mint secondary. Now, topography is really important for clarity. We specified a two-front approach, a bold, high-impact display font, like class display variable for major headings, like group names and big balanced numbers, to grab attention and establish hierarchy. Then a super clean, highly readable variable sans serif, like inner variable for all the interface text labels and data entries. Using variable fonts gives more flexibility and weight for optimal legibility. Luminous glows. This adds the luminous part. Interactive elements, primary buttons, input fields. When you click on them, they should have subtle but noticeable glow effect using the night lavender glow color, like the CSS box shadow. It provides clear feedback that reinforces the high-tech feel. So how do we communicate all of that? The function, the data rules, the specific look, identically to these different platforms through a sequence of four super detailed iterative prompts, but I might add a couple more. I don't know. Think of it like building in layers. Prompt one sets up the absolute basics. Prompt two adds the core real-time functionality. Prompt three brings in advanced features like itemization. Prompt four is all about polished reporting and final checks. Each prompt builds directly on the one before it, and the key is that the exact same text was used as input for Lovable, Tempo, and Firebase, each build at each stage. So let's dig into prompt one and see what kind of initial results the challenges typically surface. Uh, uh, what kind of initial results and challenges that typically surface. So the foundation in prompt one is gonna be our starter, and you have to absolutely get this part right. The first prompt is all about establishing the essential bedrock for Koha Ledger. We need working user accounts, the core data structure is defined properly, the initial UI shell built to match that luminous depth spec, and the fundamental security rules figured out. So the first things first, you're going to get user authentication. The prompt requires functional email and password in Google Sign. This means not just buttons, but secure backend handling of logins, password, storage, hashed, of course, session management, and providing clear feedback if login fails. Then it defines that user profile data structure, what we need to store for each user, like their display names, avatar URL, and importantly, their default currency with examples like USD, EUR, GBP. This profile data needs to be saved securely on the backend and be editable by the user later. Okay, next, the core data architecture. This is the blueprint for how all the financial information is organized. And the three main pieces, we got the group is going to be the shared space. It needs a group name, owner ID, and that critical members map, which links users' IDs to their roles, admin or member. This role mapping is the foundation for permissions. Also includes default currency and group color seed for potential UI variations. Now the expense is a single cost. It's going to link to a group, has a description, amount with 2 decimal precision, explicitly required, crucial for money, currency, date, who paid, paid by ID, and split type, like evenly by amount, things like that. The split details map is key here. It's designed to flexibly store the necessary info for whatever split type is chosen. Optional category and receipt image URL fields add more detail. So the payment is going to be for tracking direct settlements between members within a group. The prompt mandates these structures exist on the backend, and that schema validation is enforced. The backend should accept data that doesn't fit these structures. Okay, so the prompts, the first one's also going to emphasize data integrity. This means things like ensuring amounts are positive numbers with the correct decimals and referential integrity. For example, the backend logic should check that the paid by ID on the expense actually belongs to a user who is a member of that group. This prevents inconsistent or orphan data. We also included hints about indexing key fields like group name. This tells the database to optimize itself for faster lookups based on those fields, which helps keep the app responsive as more data gets added. Now the access control, this is detailed heavily because it's vital for trust. The prompt lays out specific rules based on the admin and member roles within a group. Who can read data, who can change group settings, who can manage members, who can edit and text transactions. The absolute critical instructions here, worth repeating, is that these rules must be enforced securely on the backend. Just hiding a button in the UI isn't real security because it can be bypassed. The server itself, whatever platform is running it, has to verify permission for every single action. And finally, the first prompt gives detailed instructions for building the initial Luminous Death UI shell. This includes the mandatory dark theme background, the specific CSS or equivalent for the glassmorphic panels, the exact font pairing, core color palette, mint, secondary, core is violet, secondary is mint, gold is going to be the accent. The implementation details for the luminous glow effect on the interactive elements, and specifying the phosphor icons. For consistency, the prompt wraps up by requirements. Functional initial state, working login, leading to a dashboard. As you can see at this wide screen, the dashboard must display group cards using the glassmorphic style. But critically, it must fetch and display only active groups. The currently logged in user is actually a member of currently catching the login user group and where he actually is a member of. Okay, so it also requires a functional plus new group button that persists the new group data to the backend, and clicking a group card should navigate to the group detail view, groups, group ID. Realistic loading states while fetching data are also requested. Okay, so that's a dense set of requirements patched into prompt 1. Now let's talk about what tends to happen when you give instructions this detail to different development approaches. What are the common successes, and maybe more revealing the common challenges? Generally, a major strength observed, particularly with visually focused AI platforms, is the ability to rapidly scaffold the user interface. Interpreting the luminous depth requirements, dark theme, glassmorphism requests, specific fonts and colors, it often yields a front-end structure that visually aligns well with the spec relatively quickly. We see a login screens, dashboard layouts, and style placeholder cards, and even setting pages generated that capture the intended look and feel. This initial visual prototyping speed is definitely a significant advantage um, with UI apps like this. However, a universal challenge frequently encountered, especially with automated code generation, involves the precise implementation of specific complex UI components. Modern UIs rely heavily on libraries like Radix UI, Material UI for elements like models, drop downs, complex layouts like side sheets. These libraries have strict APIs and nesting rules. While a prompt can describe the desired outcome, Glassmorphic modal opens up when the button is clicked, translating that into perfectly structured code that adheres to a specific rules of the chosen or default UI library can be difficult for automated systems. Uh, Now, we see some things illustrate, and we've run into this issues perfectly here in Tempo. We see a runtime error related to component nesting. There was a dialog trigger needing to be inside a dialog that indicates a generated code while attempting uh, the feature. It didn't follow the exact structural requirements of the underlying UI library. Likely Radix UI here, it's a common failure mode. And you see I can't really get past the login here because I decided to um, not get that bypassed. Okay. The AI understands the goal but misses the library specific implementation detail. This often requires targeted fixes, either through more prompts or manual adjustments. Um, let's see, it looks like I have locked myself out here. I've been trying over and over again to get past this, but this is Tempo's Koha Ledger, and you can see it's pretty cool. Um, but the second critical challenge applicable to any approach involving abstracted or generated backends is verifying the backend implementation, especially security and access controls. Prompt 1 mandated specific roles and server-side enforcement. While the generated UI might appear correct, um, confirming that the underlying backend logic actually implemented those security rules correctly and robustly, preventing unauthorized access or modification, is extremely difficult without deep inspection, rigorous testing, or more transparency into the backend configuration than usually available from the front end output. This verification gap is a significant consideration for any application where security is paramount. This contrasts sharply with using the prompt as a spec for a custom build, say targeting Firebase. The developer has an explicit responsibility and control to write secure backend code, implement precise database rules like Firebase security rules, and manually code the UI components to ensure correctness. The prompt guides them, but the execution guarantees come from manual expertise and testing. So the universal takeaway from prompt 1 is this tension. Automated approach offers speed on visuals and basic structure, but face significant challenges with nuanced code implementation, especially library specifics and verifiable backend security and logic. Custom builds offer control and precision, but require manual time and resources. So understanding this dynamic is key as we move into even more complex requirements in the next prompt. All right, so after assessing the state from prompt 1, lovable looking, visually strong, but with backend questions, Tempo needing a specific component fixes, and Firebase having a clear spec, the next logical step would be to feed everyone the prompts. Set next prompt. This is the prompt focused on building the core engine, functional expense payment, logging, and critical real-time balance calculations. So I provided the prompt 2 to all the platforms. And you can see here, prompts are processing. Level is going to begin generating components for the expense page, trying to adhere to those luminous step principles. Tempo, assuming those earlier trigger issues were addressed or being addressed by its AI fix attempts, would be working on implementing the transaction models and the backend logic for saving data. And here's the Firebase build process in Google AI Studio. Butterfly logo, It's generating code for the dashboard structure, details. I use Gemini 2.5 Pro and Studio quite a bit throughout this to help refine the prompts themselves. It took some back and forth to get the specifications precise. Um, Firebase Studio started generating the dashboard components pretty well. They had the group name, description fields appearing, even generated a Koha Ledger like concept, which is quite interesting. The sidebar structure for navigating looks like it's coming along. And then hit a small snag there. Looks like a routing issue or loading correctly, and that happens. We'll let it try to fix that. Meanwhile, going back to tempo, seems to be still working through those earlier component issues. While the preview of the dashboard it generated looks potentially quite nice. Good colors, layout concepts, even that 25 plus user icon, which is kind of funny. 2,500 plus user icon, which is kind of funny when we try to actually run the hosted version. We're still hitting rendering problems like that white screen or gray screen we saw earlier. So it hasn't fully overcome the prompt one hurdles to effectively execute the core logic yet. Well, prompt 2's core logic. And if you check back with Lovable, it seems to be progressing more smoothly on the front end build for prompt 2, generating components for the expenses page and dashboard navigation, generally following the design principles. It also correctly implemented the demos to dashboard button from a refinement I added to bypass login for testing, which was pretty helpful. But again, even with the UI components being generated, the core challenge of prompt 2 for all platforms remains a real-time balance calculation. Did the generated code correctly implement the complex logic to handle different currencies, parse all the split types accurately, and update instantly based on backend data subscriptions? That's the really hard part to verify without deep testing, especially for the AI builders. Okay, so acknowledging the varying states of progress conceptually, we just moved to prompt 3. This prompt introduces the more advanced real-world features, itemized expense splitting, secure receipt handling, uploading and viewing, expense categorization with autocomplete, and the detailed inspector panel for viewing transaction specifics. So I fed prompt 3 into the mix. This asks for a significantly more complex UI logic, especially for the itemization feature, plus backend interactions for file storage and potentially fetching category suggestions. Checking out Firebase build first this time. Okay, interesting. It successfully implemented the full demo access button I requested in a refinement to bypass login for the prototype focus. That purple glow looked pretty good, fits the theme. Clicking it takes to the dashboard. Seems to have progressed further through the prompt more smoothly, at least on the front end generation we saw earlier. It generated the dashboard settings. Here's an example of the expense module UI. It likely generated based on the prompt. You can see fields for description, amount, and split time selector, showing by shares here. Even a spot for I only had one slice. It visually represents the requirements well. Again, the question remains how robust the underlying logic of validation. Join demo groups like Elite Ventures, down to apartment bills. So the basic navigation and demo access flow is working here, which is great. The core structure seems solid, even if it hits some minor errors that the AI fix seemed to handle. Now looking at Lovable, as it processes the next prompt 3, it's continuing to build out the components, but sometimes as complexity increases, errors can pop up later in the process too. We see it trying to resolve potential issues, maybe related to how components using React hooks are structured or provider setups. This kind of self-correction or error flagging is common. The key is whether the platform can successfully resolve it. And Tempo, it appears to still be working on resolving those earlier component trigger issues identified back in prompt 1 based on the fixed messages. This highlights how foundational errors can block progress on subsequent, more complex prompts. It hasn't really gotten to implementing the core logic of prompt 2 or the advanced features of prompt 3 yet, because it's stuck on getting those additional UI library components. All right, conceptually moving to the final stage, prompt 4. This is about adding polish and utility. Basic reporting like spending by category, search functionality, filtering groups and transactions, comprehensive validation, client and mandatory server side, refining animations, and doing a final aesthetic audit. So I fed prompt 4 into the Firebase build process via AI Studio. It starts working on it. And yeah, sometimes integrating these final piece triggers new issues. Sometimes integrating these final pieces can trigger new issues. We see it flagging runtime errors again, maybe another component conflict like a dialog trigger or issues with dashboard page code, TSX. The interesting part here is the self-correction capability. It can just tell this AI fix the error, and it attempts to analyze the problem and generate corrected code. It doesn't always succeed on the first try, but it's a powerful workflow feature. So checking back on Lovable, and Tempo unfortunately seems to still be stuck on those foundational component errors from prompt 1, preventing it from fully implementing the core logic of prompt 2 and 3, let alone 4. Trying to run the app still results in rendering issues. It built a really nice looking landing page conceptually, but couldn't get past the login component hurdles in this particular run. Just to give every platform a final chance, I actually created one last consolidated prompt, telling them to remove login entirely, fix all existing errors, enhance the UI further, and complete all features from prompts 1 to 4. I've fed this final instruction into all 3. And here's where we landed. Lovable seems to process the final prompt reasonably well, presenting a visually polished dashboard and functional looking components, though it flags some potential React hook errors itself that might need addressing. It definitely completed the most visually. It definitely completed the most visually on the front end. Tempo unfortunately timed out or like remaining stuck on the early errors. Couldn't recover the session. Maybe hidden. It's not really hitting operational limits. It's more like user error. But Firebase, well, it seems to have gotten stuck in processing loop or hit a significant error trying to integrate everything from the final pass of prompt. And you got with a spinning blue circle. Sometimes asking too much consolidation and fixing it like all at once can overload the generation process. So what is the whole process telling? We gave identical complex prompts to Lovable, Tempo, and Firebase. Lovable showed real strength and rapidly generating a high fidelity front end UI that closely matched the Luminous depth spec. The questions remain about its automatically generated backend logic's depth and security. Tempo demonstrated it got understood the requirement. It got tripped up by specific common technical hurdles related to UI library implementation. And that's going to highlight the challenges AI faces with nuanced code structures and error recovery. Now, the Firebase approach, guided by the prompts, showed potential for building complex features and even attempted self-correction on errors, but also hit limits when faced with extreme complexity or possibly integration issues requiring careful step-by-step guidance rather than one giant fix everything prompt. So the key takeaways seem to be AI builders excel at rapid UI scaffolding. Sorry, I always say that kind of weird. AI builders excel at rapid UI scaffolding based on detailed visual prompts. Um, Implementing complex UI library components perfectly can still be a hurdle for AI generation. Generating robust, secure, mathematically accurate backend logic, especially for real-time financial calculations, purely from prompts remain a major challenge. Verification is crucial. Iterative prompting and error handling are essential parts of the workflow. With current AI tools, they don't always get it perfect on the first try, especially with complex specs. And custom builds offer control and precision, but require significant manual effort, whereas AI offers speed with potential trade-offs in depth or accuracy for highly complex features. So that was our comparative build for Koha Ledger, a really interesting experiment pushing these different platforms with the same demanding instructions. It definitely showcases the power and the current limitations of AI-driven development for sophisticated applications. I'd love to hear, your thoughts on the process and these platforms. Have you run into similar challenges? Let me know in the comments if you found this breakdown useful. And if you want more deep dives into prompt engineering, AI tools, and building complex projects, definitely hit that subscribe button. Thanks for watching. Appreciate you sticking through the detailed analysis. This is Marwan King AI, signing off.